All right, so intro to OTP in Elixir. Who has heard of Elixir here? All right, good. Most of the people here. Who's actually used programmed in Elixir? Ooh, we got one in the back. All right, so I'm going to guess, has anyone here heard of OTP? Okay, we got a couple, good. So OTP is, Erlang was built in 1986, and then OTP was kind of like combined with it, and it was released open source in 1998. And so Erlang and OTP kind of came out. It's been around for like 20, 30 years now, on 98, so whatever that is. And it's kind of has a lot of parts to it. So here you can see a list: Erlang, the programming language, and the compiler. That's part of OTP. It's got a bunch of tools for like in-memory data storage. There's a database server analysis tool. We're not going to cover any of the tools today. There's a bunch of libraries, like there's the supervisor library, there's generic server, and a bunch of other libraries, and we're going to cover some of those today. And then there's design principles, and those are part of how you use generic server and supervisors. And then there's other stuff, because there's just a ton of stuff to OTP. And so there's some stuff like how to release applications and some stuff like that. And OTP is huge, so we're not going to cover that stuff today. So the main thing in OTP is your processes. Everything in OTP runs in processes. It's like your basic building block for OTP. And it's not like an operating system process, so when you spin up an OTP process, it's just like super light. Like you can, like on a laptop, you can like spin up just like thousands of them, because they're just like an internal process that's super lightweight. Doesn't have to deal with all the stuff that like an operating system one does. So let's go ahead and, well, I'm not going to live code it, but I'll show you what it's like to spawn one real quick. So here we are in IEX, which is, if you use Ruby, it's kind of like IRB. It's the REPL for Elixir that lets you kind of just run some live code. So to spawn the server, spawn the process, we're going to run spawn, and then we're going to pass in a function. So our function is, all it's doing is it's going to print out hello full stack. So it's real simple. So we run it, and there we go. We got our hello full stack, and then we've got this weird looking hashtag PID 0.64.0. So what that is the process ID. It's like the mailing address for that process so that you can track it. So what we really want to do is track that from the beginning. So we'll run that again. This time we'll assign it to the variable PID so that we have that process ID and we can keep an eye on it. And then we run process alive, and it says false. So what happened, the process runs, it prints out our hello full stack, and then it dies. So process just kills itself as soon as it's done doing its task. So if you're doing one like printing hello full stack, it's like pretty much instantly dead. It does its thing, and then it's totally done. So what if you're doing a longer process, or you're doing a longer function that's going to take a while, and it fails partway through? So that's where we run into error handling. One of the common phrases that you'll hear when you look into Elixir and Erlang and OTP is "let it crash," which sounds terrifying because letting it crash usually means, well, you have to kill the whole app. That doesn't make any sense. But with OTP, you're running all these like hundreds or thousands of little processes, and all you're doing is just crashing that tiny little one. So you don't have to restart your entire app. It's just this one little piece that gets to restart. And the reason this works really well is when you think about like any sort of, like if you think about a computer or your app and like something goes wrong, you can't figure out what's going wrong, the easiest way to fix it is to just restart it. And it's the same with like everything, like my kid's electronic toy or your TV, your video game console, or your phone. If you get to a point where it's just like, I don't know how to fix this, but if I restart it, that'll fix it. So this is taking that principle and applying it to our code. So if something goes wrong in a process or some function's running and it fails somehow, we just can restart it. So the reason this works is because you're clearing out the state. Because what happened is while it was running, some combination of stuff happened and the state got messed up. And so that's why restarting works, because you're just giving it the fresh state, start it over, and give it clean slate or a clean state. So how this works in OTP is with supervisors. So there's a supervision tree that's kind of based on this principle. So in this example, these are all processes. Some of them are marked as supervisors, and the supervisors just have two simple jobs. They start up other processes, the ones underneath them, and then after they start them up, they track them. They just keep an eye on it, and if one of those worker processes crash, then it just restarts it. And that's, like, this is a really simple tree to look at, but this is freaking awesome. Like, anything goes wrong in your app, and you have supervisors watching everything, and it can just kick up and restart that process like that. It's pretty rad to see, like, when you're working in apps, you just can run something, kill it, and it just restarts like instantly. It's pretty awesome. And so just like that, you got the supervision tree, and now you never have to do any error handling again. It's pretty awesome. It's a lie. You do have to do error handling. Do you have a question?
Yeah.
Whoop, sorry.
The supervisor's job is just to spin up processes and then just monitor them. Then what's the supervisor's do?
So that one is watching. So in this example, say that the far right worker crashes, and the supervisor restarts it. The supervisor right above it restarts it. If it restarts it a couple of times and that doesn't fix the problem, then it'll crash itself. So it's keeping an eye and it's kind of restarting, and it's like, this didn't fix it, I'm gonna kill myself. And then the supervisor above it will restart it, and that'll cascade down. So it can kind of cascade up if you have like a really bad problem that's kind of infected in there.
And then at the very top of the tree, if that one fails?
Yeah, well, then you're in trouble. That's the whole, like, you know, who watches the watchman. At some point you get to the top and like, well, the whole thing's just toast. And actually, so there's a thing, I was joking that you don't have to do error handling, but you do. And the reason, like, when I first heard about this, I was like, okay, it sounds great, but what if it's just broken? Like, what if my worker over here is just bad? Like, restarting it isn't gonna fix that worker. It's just gonna restart and run it again. It's not gonna work. Even if it goes all the way up, that worker is still broken. So this doesn't fix that. You still have to do that. Hopefully you catch that before it goes to production, just like you normally have to do. I mean, that's the sort of thing you should catch in testing. And there's a great article called The Zen of Erlang by Fred Hebert, and he kind of talks about this. So he says there's basically 4 kinds of bugs that you have in your code. There's the kind that are really easy to repeat, so you can see how it's breaking and try to fix it. And sometimes that's on a core feature, and sometimes it's on a secondary feature. And then there's the transient bugs. Those are the ones where you get the bug report, and you're looking at it, and you're like, I can't get it to do it. I don't know how this person made the app do this. I'm trying to get it to happen again, and it won't happen. And those are the kind of bugs that are really hard to find before you push to production. Because, like, you don't have this whatever weird combo of stuff that messed up the state. You usually can't do that, and so it goes to production. And because of that, yeah, this slide sort of says that those kind of bugs happen all the time because they're really hard to catch. The really great thing about those kind of bugs is restarting the process fixes it. Like, restarting is not gonna fix the easily repeatable bugs, but it's gonna fix the ones that you can't catch. Because as soon as it crashes, like, that supervisor's there and sees that it's crashed and just restarts it, and now it's got a brand new fresh state. It's pretty magical. I love this. The more I'm like researching OTP, the more I'm like, this is just amazing. So yeah, it's awesome. All right, moving on. So processes in Elixir they're completely memory independent and they're completely isolated, but obviously they have to be able to communicate to each other. So they do that with messages. So every process has the ability to send and receive messages, and the process ID we passed around earlier, that's how we track the processes, and that's basically the mailing address, like I said earlier. Every process has that mailing address, and they also have a mailbox where messages that are sent to it, you just go into that mailbox, and then the process has a way to handle those, and we're gonna go over that. So let's see how this works. So we're gonna build a real quick basic fantasy football app. I'm a huge fantasy football fan. I'm a little bit bummed that I did not see that the first regular season game starts like today, so we're missing it right now, but that's okay, I'm really excited to be here. But we're gonna build a quick app that just lets you build your fantasy team, add players to it, remove it, and track your team that way. So, and we're gonna, over the summer, I wrote like a quick Elixir wrapper for a Fantasy Football Nerd API. So we're going to use that kind of in the background to get player data as we do this. All right, so one thing with this, so Elixir is immutable. You might have heard the data in Elixir is immutable, which makes state a little bit tricky to store because you can't just like mutate the state. And normally you get to this point, like, okay, so we got to save the state. And your kind of traditional object-oriented programmer might say, all right, time to make a database. Got to get it to the database somehow. That's really kind of counter to how a lot of people, especially in Erlang, but Elixir too, which, sorry, the communities are kind of like coexist, but they're a little bit different. Anyway, totally side note. But they try to hold off going to a database until like that's the last possible thing, because the process, like you can have processes running for years, and I'm going to show you right now how to store state in a process instead of a database. Okay, so here we've got some code. Can you guys all see that okay? Good, because I can't actually change the size, so I'm glad you can see it. So this is that basic process we ran. Like this is it, ready to receive messages. So we're gonna, I know it's a lot, we're gonna go through it line by line so you kind of understand what's going on here. So we start off, and we have the function that's called start link. So that starts up the process. And the start link's just like a common name that's used. And so that function does spawn link, which is similar to the spawn function we used before to kick up a process. And then it's got 3 arguments. So the first one is this module, all caps with double underscores on both sides. All that does is it references the current module that you're in. So basically at compile time, it's going to change that to fantasyteam.basic, which is the module name at the top. And so that's just like a reference back to this module. The second argument we have here is loop. That's actually going to tell the process, so it's going to tell the process to look back at this module that we gave it the name of, and then run the loop function, which is what we're going to go over next. And then the third argument here is this is the list of arguments that's going to go to the loop function. In this case, there's only one argument. Loop just takes one argument. And so we've got inside of that, this is called a map, which is kind of like a library, like a key value store is what a map is in Elixir. So let's go look at the loop function. So we have loop state here. So state's that empty map that we created before that we send to the process. So now the process starts to run this function, takes that empty map, and then it starts this receive block. So receive do sets it up to receive a message, and now it just sits here. So remember before we had the process, it printed out hello full stack, and then it died. So this process isn't going to die because it's sitting there waiting for a message. So we have defined here the first message that it can receive, which is a tuple, which if you don't know what it's basically like a small list. So it's got 2 items in it. The first one is an atom, which is like a symbol if you use Ruby. Anyway, so that is just identifying what kind of message this is. So the message here is we want to add a player. So the first thing is add, so that we tell the process which function we want to do here, and then the name is going to be like Russell Wilson in quotes. So then it takes that name, it uses our like external thing that goes to the API and gets the data for that person, and then it applies it to the player variable. So now we got player, which is all the information like the team, Seahawks, position, quarterback, all that sort of stuff is now assigned to a player. And then we go to the next line here, and this is defining the new state. So we take that name, Russell Wilson, we take the player info, which is all of his stats, quarterback, team, all that, and then we're applying it to the current state, which is an empty map. So basically, once we run this line, we're going to have a new map that has one key in it, and it's Russell Wilson, and the value for that is all of his stats. So if we just stopped here, though, that's where the process dies, because it's processed a message, and now it's done doing its thing. So instead, we call the loop function, which goes back to the top and starts the whole thing over again. So the loop here takes that new state, so it takes that map that's got Russell Wilson in it with his stats in it, and then it carries that back up to the top. So then you rerun loop function. The state is now that map with Russell Wilson, and now you're waiting to receive another message. So next we have the remove message, and that's pretty much the same thing. You don't have the line to get the stats because that doesn't matter, but you're taking that state and now you're removing that name from the state, and then you're looping it again with the adjusted map. And then the last function we have, or the last message, sorry, that we have is the team. So this is, we're asking for, like, we want the team. Who's on the team right now? And so that actually, the first one you see is the team atom, and then the second argument is the PID. So we're actually, when you call this message, you have to give it your PID so that you can get it back. So like if we were in IEX is a process. So if IEX sent out the message team, it would also send out its own PID so that so this process would know where to send the team info to. So it does that with this send. It sends to the PID, and it sends the state to that PID, and then loops again. The state doesn't change at all, so it's just loop state. So let's see this in action real quick. Okay, so we're in IEX, and we're gonna go ahead and do that first start link, and we're gonna assign it to a PID. So now we spun up the process, and we have the ID for that process. Now we're gonna send it a message. We're gonna send to the PID, add Russell Wilson. We get the return that just tells us what was sent. And then we're gonna go ahead and add another player. We're gonna add Doug Baldwin. So now we've got 2 players on our team. And then just to test it, we'll remove Doug Baldwin, and then we'll call the team. And see, when we send the message calling for team, we don't get the team back because what happened is we got a message sent back. And IEX we haven't built a receive block for it. So right now that message is just sitting in the mailbox. But with IEX, we can just flush the mailbox. So we flush it, and then we can see, okay, that's the team. So we get the information, Russell Wilson, position quarterback, team, Seattle. So this is the process that did that. Is there any questions at this point? Does this, like, in general make sense, or is there any specific questions about this?
I just had a quick question about the scoping of the variables. Are they just all block scope?
I believe so, yeah. Anything else? Okay, I'm gonna move on, assuming you understand everything. So, all right, so now that we've done this basic process, this is a super, super common pattern in OTP. Like this, because this is how you basically build a process that can send and receive messages. It's so common that they've created the generic library to cover it, which they call GenServer. And like this is great right here, but it's actually missing a lot of tiny little edge cases. Stuff like tail call optimization, avoiding deadlocks, message ordering, a bunch of other things like that they've kind of discovered over the past 20 years of using Erlang and OTP. And so because of that, they've fixed all those, and then they hide it away in this thing called GenServer. So we're gonna take our process and we're gonna convert it to GenServer now. All right, so here on the right, we have the process that we just went through. The code for that process, and then on the left, this is what it looks like in GenServer. You see it's some grayed out, you probably can't even see it at all. There's a little bit of extra code right there. We grayed it out because that's more like a convenience function. So you can sort of see that it's about the same amount of code outside of the convenience functions, and we'll cover those too. So we'll go down the line. First, you start off and you put use GenServer. That's what gives you kind of all the magic for this module. And then now we'll compare the stuff that's all basically kind of the same. So first we have start link, and on the left, now instead of doing the spawn link to spawn the process, we do genserver.startLink. And we pass in the module, and then we don't have to pass in loop because GenServer is using kind of its own loop function that it doesn't need us to provide one. So it's kind of doing its own stuff behind the scenes. So we're passing module. The second thing's, okay, you don't have to worry about that one. That doesn't really matter. And then the third thing is arguments, and we don't have any arguments in our situation here. So after that, we have callbacks. Oh, do you have a question?
Yeah, I'm wondering what happens if you don't match the record, the tuple. In this case, is it going to just fail, or does it just silently move on to the next message? And that's part of that.
Are you talking in the right column?
Yeah.
Oh, yes. So if you do not match it, which like we just sent like, I don't know, what some random word, whatever, it would just sit in the mailbox. And usually what you can do, I don't have it on here, usually you can add a final thing that's just like an underscore, and that's like a catch-all. And you can just like throw up an error message. Because if you don't do that, you could run into problems where it's like the mailbox for process gets flooded. And there's, I don't know what it is, but at some point that could like be a real big issue.
So then moving over to the Gen server case, does it automatically implement that catch all and just move on to the next message? It'll consume it and move forward?
Yes. Actually, I'm not sure. You might have to do that manually. I'm not sure. So we're just going to ignore that for now. All right. Yeah.
So in the context of a little while back, you mentioned where the process, you have the supervisor process that restarts, right? Now there's these messages that are sitting. What if there are messages in the queue that are not processed yet, and you restart the process?
So actually, when I say like restart the process, it actually the process itself dies, and you like code in a way that when something goes wrong, it kills itself. So you're actually starting a brand new process that just has the same starting state. So it's not actually restarting that process. So those messages would just be gone. Yes, yeah. You can work around that. Like if you needed something to store that, you could like duplicate those messages elsewhere. But the general vanilla case we have here is they would be gone, because you're starting a brand new process. It just happens to be in the same place with the same state.
I'm thinking of the server, and the server might have a lot of processing to do. It might have messages.
Right.
Just destroying those messages is not a good idea, and they will do something with them. In which case, this is not the right solution for this case, right?
Possibly. I don't know the answer. So yeah, so I don't know the answer to be able to help with that. Okay, so we're going to go back. So the first thing that happens when the first line, the start link, and you get the Gen server, and that kicks off the process, the first thing that it's going to do is go back to the module that you gave it and say, okay, where's your init function? And that's what we have right here. And so that matches the OK that we provided in the first one. And then Gen server is expecting this tuple that starts with OK, and then the second argument there is the state, which again is our empty map. So we want to start the process with an empty map. So now we're going to handle our first message. So in this case, we don't have a giant receive loop. Each message is handled in like its own function. So there's two kinds of messages actually in Gen server. There's casts and then there's calls. So a cast is like our add remove, where we're sending something to it, but we don't need a reply. And then a call is you send something like for team, you want to hear back like what's the team. That's the point. You're sending a message and expecting a reply with a call. So here we're doing a cast. So you handle casts with a handle cast function. And then you can compare over to the right. So the first argument in handle cast is the message we're expecting to receive, just how we listed over there on the right. And then the second one is the state. So previously we had that loop function that kind of held all the messages, and that kind of is where the state came from. In this case, the state is in the handle cast function. And then these two lines, they're exactly the same as before. And then instead of calling loop, since there is no loop, you just return a tuple that starts with no reply because it's a cast, it doesn't need to reply to anybody, and then the new adjusted state. And this is something that Gen server is expecting this return, and so it takes that state and saves it. Same thing as before, the remove is basically like the add, just without the line that gets the player data. So that just adjusts the state and does the no reply tuple. And then we have handle call. Handle call is slightly different. It's got 3 arguments instead of 2. The first one is the message, which in this case is just team. The second argument is the PID of the sending process. In this case, we don't need it, so we just put an underscore before it, so it'll just ignore that, but we put from there just so we know what it is. And then the third one is the state. And handle call is expecting a reply. So you get a tuple with reply at the beginning, and then you have state twice. And the reason you have state twice is the first one is what is going to return to the calling process, and the second one is what's going to save as the state. So like, for example, if this instead was like handle call quarterbacks, and you have a whole team of a bunch of different players, the first state there would be just the quarterbacks, And the second one would be the entire team, because you want to save the entire team as your state. So yeah, so that's how that part works. Okay, so how do we actually make these calls? It's a little bit different with GenServer, which is why we have those convenience functions that I showed before. So at the beginning, we had the start link that we already went over, and then we're just defining a really simple function, add with the PID number of the process and the name, and that's going to do PID process and the name, and so that's going to do GenServer cast, and then it's going to send that to the right PID with that message. So all you would have to do is call the module name fantasyteam.mygenserver.add the process PID number and then Russell Wilson, and then it's going to go through that whole message thing. So you shouldn't be worrying about the messages. That's kind of happening behind the scenes. And then team is basically the same, but it doesn't have a name, just the PID. And then it does GenServer call, and that's basically the same. So now we have, this is our GenServer version, which is a little bit longer to look at than the basic one, but it's better because you don't have to actually manually send messages to use it. You just have to call the function add, remove, or team. Cool. So we can do one thing a little bit better here. In this case, I'm not using this to let a whole bunch, I don't want a whole bunch of teams. I just want one. So I can make this a single server, or like a singleton, kinda. Well, it's a little bit different. And so on the right is the code that we just had, the GenServer code, and on the left is just very slight adjustment. We're going to add this name at the top, so we're naming the process, or we're just creating a module attribute that we can use later, which has the name of the module, fantasyteam.singleserver. And so we're going to place that in here in the arguments. So then now when you spin up the process with your start link, it knows that it has a name, so you don't need the process ID because it has a name to call directly. And then because of that, we can take the PID out of these GenServer casts because it doesn't need to call the PID anymore, it can call the name directly. And that's great because now people don't have to have the PID as an argument, which is great because it can be, in this case, it'd be really dumb to have to remember the PID every time when you're just trying to add a player to your one server. So that's great. So it makes add only a single argument, just the name, remove just has the name, and then team doesn't even have any arguments anymore. So yeah, so let's see that real quick in IEX. So we're going to call this up. We'll do fantasyteam.singleserver.startLink. We don't need to capture the PID this time because it just created that process, and we already know the name of it because it's the same name as the module. We're going to add Russell Wilson, so we just call fantasyteam.singleserver.add Russell Wilson. We get an OK response just to affirm that it went through. And then we do the same. We add Doug Baldwin. Now we're going to remove Doug Baldwin. We get a bunch of OKs, and then we're going to call the team. And this time we don't have to flush the mailbox because it's giving us the team as the return rather than having to send a message back. So it makes it really easy because then you can just do fantasyteam.singleserver.team equals team, and now you have team, or team equals that. So now you have it in a variable. So it makes it a lot nicer than having to send a message and receive that. Okay, so quick recap. So we built a GenServer, and this allows us to keep the state and functionality in a process, which is great because now we have the benefits of the supervision tree, and it's fault tolerant for the transient bugs that we were talking about. And it's just, because the processes manage their own state, it's a lot easier to reason about. And it's got a bunch of other really cool OTP things that I just don't have time to tell you about. But it's awesome. Real quick, a little bit over time, so I'm going to wrap up real quick. Elixir has a couple of extra things called agents and tasks. So our GenServer is just basically holding state. You can add and remove from it, and then you're just holding state. We're not really doing any complex operations or anything. So tasks, but we could, because we could just add another message that did a thing like that. Tasks and agents are kind of like splitting of a GenServer. So a GenServer can store state and it can do all the complex operations, whatever. Tasks is a great way to do parallel or concurrent tasks. You want to send it just a whole bunch of work, and it's going to automatically spin up processes and use all the different cores on your machine and everything. And it's like 2 lines. It takes no work to do that. And then agents is the opposite. It doesn't do any of that stuff, but it's really simple and basic at storing state. So I'm not going to go over it, but this is the same as the Gen server that we wrote, just in an agent. So agent just has like a start link, get an update. It's like a really kind of basic version of Gen server. So if you know that a process is just going to be storing state like currently we do, then this would be a much easier way to do that. Okay, that's all I got. There's a lot of awesome resources to learn more about Elixir. The community is really great. They've got an Elixir Slack group, and I highly recommend going there. Everyone there is like incredibly friendly and super helpful. And there's a really great book that I've been reading called The Little Elixir and OTP Guidebook. It's by Benjamin Tandway Ho, I think it's pronounced. And it's fantastic. Highly recommend that. And I have a link, bit.ly full stack OTP, with some other links to videos and other learning sites and books that if you want to learn any more about this, that's a great place to do that.